Hi, my name is Tommy. Today I'm going to demonstrate a resilient Java microservice with Istio journey. Istio is a collaboration among IBM, Google, and Lyft that provides a service mesh architecture to help you manage your microservice on Kubernetes. The microservice example we're using is called Microprofile Conference. It's built with an Angular front end with 5 microservices. So let's get started. The prerequisite for this journey is to have Kubernetes cluster ready with Istio. So let's go over how to deploy Istio on your Kubernetes cluster. So under your prerequisites section, you should see this link. Click it. It should redirect you to this instruction. First, you want to install the Istio release from here. After that, extract it, and you should see a repository called Istio with a version number. Go into the repository and copy the binary to your local bin. Next, we want to check what RBAC your cluster has. So run this command. So my cluster have an alpha RBAC. So apply this YAML file on your cluster. Next, we want to apply the Istio control plane in your cluster. So run this command. And you should be able to see all the necessary components for Istio is on your Kubernetes cluster. Next, let's build our microservices. Before you continue, make sure you have Maven and Docker installed on your machine. So now, let's git clone our journey repository. Then go into our repository. You can also use this script to build all your necessary microservices and push on your Docker Hub. So run this script followed by your Docker Hub username, and the script should build all the necessary components for you. Or you can go over git clone each directory manually and Maven clean package for each repository. Then Docker build and push each images. Now let's move on to step 2. For those of you who build the images manually, make sure you change the image name in your YAML file to your own Docker username. So now, let's apply the necessary YAML file to a Kubernetes cluster. And since it will take 5 minutes to build all the necessary components, so let's wait for 5 minutes. Let's run kubectl get pods and make sure our pods are running. Then, since we need to access our microservice using Istio, we need to create an ingress gateway in order to access our microservices via Istio ingress. So let's apply the ingress YAML file in our Kubernetes cluster. And after you create the ingress gateway, you could use this command to see the website link for your microservices. So go to a browser, apply this link. You should be able to see your application and microservice is running on this site. Now let's explore some Istio resiliency features. A circuit breaker is a critical component of distributed system. Istio envoys can enforce circuit breaker limits at the network level instead of configuring and coding each application independently. Now we will show you how to use circuit breaker to limit maximum connection and pending requests for your applications. Now let's look at our circuit breaker rules. We have the maximum connection and maximum pending requests set to 1. Thus, if there's more than 2 requests coming at the same time, the endpoint will drop all those extra requests. Applying the circuit breaker rule is simple. Just use the Istio binary and create the YAML file on our Kubernetes cluster. Then our rule is set to our applications. Now go to Applications and open Developer Tools. Go to Network, select a speaker and a section. You try to do like multiple volts. First few volts will get passed, but the rest of the volts will be existing the maximum connection and pending request and return a 500 service error. Circuit breaker also can help you eject any broken parts out of the load balancing pool. A load balancing pool is a set of instances that are under the same Kubernetes service. Now look back to our circuit breaker rules. It says if any parts have more than one consecutive service error within 1 second, the circuit breaker will eject that part for 15 minutes, 100% of the time. For our scenario, we will create a broken part that will always return a service error to demonstrate how circuit breaker could eject that part for 15 minutes. So now, let's apply our broken parts on our Kubernetes cluster. To demonstrate these examples, we want to remove the maximum connection and maximum pending request from the circuit breaker rule in order to avoid extra service error producing from the applications. So, comment out these two lines. Then we want to use Istio replace to apply our new rules. So now only the broken parts will produce service error from our applications. So we'll go to our applications, select a section and try to vote multiple times. As you can see, only the first time will produce a service error from the broken parts. The rest of the traffic will be routed to the other parts, and the broken part will be ejected from the load balancing pool. You can also double check it using the kubectl logs. So let's get our broken part name and do kube logs, part names, then +Cs, and the number of logs you want to show. As you can see, only one of the HTTP requests gets sent to the broken part. The rest of them are routed to the working part. Before you continue to the next step, please remove the circuit breaker rules and the broken parts. Now let's go to step 5. We'll show you how to apply timeouts and retries on your microservices. In these examples, we will apply a 1-second timeout on the vote part, so any request that takes more than 1 second to respond will be timed out. And we will also apply a fault injection to the CloudDB, so it will take more than 1 second to reply back to the vote part in order to demonstrate how the timeout works. So let's look at the timeout files. It will time out when there's more than 1 second. You could also apply a retry rule, the attempt-free retry if there's a timeout. So let's apply our timeout rule. And in order to test that, we also need to apply our fault injection rule that produce a 1.1 second delay on our CloudDB. So now you go back to our Microservice conference app and try to vote. You will always return a 504 timeout error. Now you know how to deploy your microservices using Istio and apply Istio resiliency features. Thank you very much for watching.